Hello everyone, in this video I will explain the priority scheduling algorithm, which is one of the CPU scheduling algorithms used in operating systems. Priority scheduling can be preemptive or non-preemptive. In this algorithm, the CPU selects the process with the highest priority to execute first. Usually, a lower priority numbers means higher priority, so a process with priority 1 is more important than a process with priority 3. Priority scheduling works by assigning a priority value to every process. Here is how the algorithm works step by step. First, each process is given a priority number. Second, all processes wait in the ready queue. Third, the CPU checks the priorities of the ready processes. Fourth, the process with the highest priority is selected to run. If the algorithm is non-preemptive, once a process starts running, it will finish before the next process runs. If the algorithm is preemptive, the running process can be stopped if a new process with higher priority arrives. Important terms used in priority scheduling. Arrival time, the time when a process enters the system. Burst time, the total CPU time needed by the process. Priority shows how important a process is. Waiting time, how long a process waits before execution. Turnaround time, total time from arrival until completion. So this is the sample process table. P1 or process 1 arrival time is 0, the burst time is 6, and the priority is 2. The process 2 is the arrival time is 1, the burst time is 4, and the priority is 1. In process 3, the arrival time is 2, the burst time is 5, and the priority is 3. The process table tells us when each process arrives, how long it needs, and how important it is. The CPU uses this information to decide the order shown in the Gantt chart. This Gantt chart shows how the CPU executes each process over time in non-preemptive priority scheduling. The numbers at the bottom represent times units, and the boxes represent which process is using the CPU. From 0 to 6, P1 runs first. P1 starts at time 0 and finishes at time 6. Even though P2 and P3 arrive earlier, P1 is not interrupted because the algorithm is non-preemptive. From time 6 to 10, after P1 finishes, the CPU checks the priorities. P2 has the highest priority. P2 runs from time 6 to 10. From time 10 to 15, only P3 is left. P3 runs from time 10 to 15. In non-preemptive priority scheduling, once a process starts running, it continues until it finishes. The CPU only checks priorities after a process completes, not while it's running. This Gantt chart shows that processes are executed one at a time, without interruption, based on priority order after each process finishes. Waiting time calculation. So waiting time is the time a process waits before it starts running. We compute it by subtracting the arrival time from the start time. So the formula is waiting time equals start time minus arrival time. So the waiting time of P1 is equals to 0. Waiting time of P2 is equals to 6 minus 1 is equals to 5. Waiting time of P3 equals 10 minus 2 equals 8. In turnaround time calculation, turnaround time is the total time from arrival until the process finishes. We compute it by subtracting the arrival time from the completion time. Turnaround time is equal to completion time minus arrival time average. So turnaround time of P1 is equals to 6 minus 0 is equals to 6. Turnaround time of P2 is equals to 10 minus 1 is equals to 9. Turnaround time of P3 is equals to 15 minus 2 is equals to 13. So these are the disadvantages and the advantages of priority scheduling. First is the advantages. First is the important processes are executed first. Second, useful for critical and real-time tasks. Third, can be flexible because it supports preemption. And the disadvantages is the starvation may happen for low priority processes. Second, priority values may be unfair if not managed properly. And best used in the priority scheduling is real-time systems. Systems where some tasks are more important than others. So in summary, priority scheduling selects processes based on importance, not just arrival time or burst time. It is very useful for critical tasks, but it can cause starvation if priorities are not controlled. Compared to FCFS, priority scheduling focuses on importance. Compared to round robin, it does not guarantee fairness for all processes. And that's all. Thank you for watching.